cranes, booms, bridges, trolleys, hoists, cables, operators. All essential elements of a safe lift. But proper rigging is the ultimate final means of attaching and supporting the load. In this program, Rigging Safety, we will discuss the role of the rigger, the different types of slings used, proper selection, use, and care of rigging equipment, and safe work practices. Though the crane operator ultimately controls lifting, traveling, and setting the load, the rigger plays a critical role in its successful execution. With the use of pendant and radio-controlled cranes, you may be responsible for both rigging and lifting the load. In a report by the Department of Energy using Bureau of Labor Statistics, 2 of the top 4 crane incident categories involve the rigger. The key to preventing crane incidents is understanding and respecting the potential hazards associated with hoisting operations and proper planning and knowledge of the lift. As a rigger, your responsibilities include knowing the stability and operating characteristics of the equipment used, identifying the potential hazards in the area, load weight estimations, rigging equipment selection and inspection, rigging practices, hand signals, load control and dynamics, sling types and application, proper handling of slings and rigging components, and safe work practices. As with all functions, knowledge and preparation are the keys to safety. The amount of preparation for a lift can vary from site drawings and plans to visual observation. Variables that influence the amount of preparation required and whether a lift is classified as critical include the type of lift being performed, the frequency it is performed, and the environment in which it is performed. A lift is classified as critical if collision, upset, or dropping could result in a significant adverse health impact, a significant release of radioactive or other hazardous material, damage that would jeopardize operation or the safety of a facility, or the load requires exceptional care and handling. As mentioned earlier, a rigger's responsibilities involve more than just attaching the load. The rigger needs to be familiar with the limitations and capabilities, including weight capacity of the crane, hoist, and other equipment used. Potential hazards should also be identified and eliminated or controlled before the lift. Potential hazards include overhead power lines, underground services, uneven or unstable ground, workers in the area, buildings, equipment, and other physical objects, hazardous materials, corrosive substances, inadequate lighting, radio interference, and more. It is important to know what is being lifted and how much it weighs. There are different ways to determine the weight if it is not marked or unknown. Look for printed material accompanying the object that provides its weight. If the object is still on a truck, weigh the truck. The weight can also be calculated using the object's dimensions and a table of common material weights. Knowing what you are lifting, how much it weighs, what equipment will be used to lift it, where it will be traveling to and placed, and the potential hazards associated with the lift are important components in rigging safety. It is also essential information for the selection of proper rigging equipment. There are a variety of different slings used in the workplace. These include chains, wire ropes, synthetic webbing, metal mesh, and more. Make sure the slings selected and all other rigging equipment are appropriate for the lift. Factors to consider when selecting a sling would include: does it meet the weight capacity? Is it the right material? Will they attach to and support the load? Can the rigging damage the object being lifted, or the object being lifted damage the rigging? Are there potential hazards in the lift environment such as chemicals, heat, confined quarters, or more that can have a negative impact on the sling? Is the rigging the proper size? Many rigging incidents have occurred because of improper selection. When the rigger attempts to improvise instead of using the proper equipment, the potential for an incident increases. Even though all slings are proof tested by the manufacturer prior to initial use and inspected on a regularly scheduled basis by a competent person, all rigging should be inspected by the rigger before each use. With chain slings, check the chain and attachments for wear, nicks, cracks, breaks, gouges, stretching, bends, and weld splatters, and discoloration from excessive temperature. When inspecting wire rope slings, look for wear, cut strands, kinking, bird caging, and other visible signs of distortion. Synthetic web slings should be regularly inspected for broken or worn stitching, excessive abrasive wear, acid or caustic burns, or other visible damage that may affect the strength of the sling. Any sling that appears to be damaged must be tagged and removed from service. All slings used must be within the rated load of the sling. Web slings contain a load tag with its rated capacity on it. The load capacity of chain and wire rope slings is determined by their diameter. The rated capacities in manufacturers' guides and tables are based on newly manufactured slings. The capacity of the sling may be affected by factors such as temperature, bending, the number of legs, and the angle of the sling. Depending on the type of sling used, environmental temperatures can affect its strength and capacity. Follow the manufacturer's recommended guidelines when using slings in hot or cold environments. Bending a sling, such as a wire rope, causes extra stress on the outside strands, which are required to stretch further than the inside strands. This causes a reduction in the sling's capacity. The angle of the sling also affects its load capacity. As this graphic illustrates, the greater the angle, the higher the tension on the sling, and the greater the reduction in its capacity. The angle of the sling is determined by extending a vertical line through the center of the hook. The angle can be reduced by using a longer sling. An object should be rigged so its center of gravity is directly under the hook. An object's center of gravity is the point where the object would be perfectly balanced on a fulcrum. The center of gravity of a symmetrical, uniform object is located at the object's geometric center. With irregular-shaped objects, the center of gravity may be located outside of the object's geometric center. With imbalanced or irregular-shaped objects, different length slings may be needed to place the object's center of gravity directly under the hook. An unbalanced load can create a greater force on the rigging than the actual weight of the load itself. Whether a vertical hitch, choker hitch, basket hitch, or other means of attachment is used, the goal is to safely secure and control the load. All rigging hooks, rings, shackles, sockets, and other sling attachments should develop the full rated capacity of the sling. All rigging attachments should also be inspected before each use for signs of defect. It is important you understand and respect the capabilities and limitations of the attachments you use. For example, the capacity of a shoulder eye bolt is dramatically reduced on non-vertical lifts and should never be used on angles more than 45 degrees. The purpose of proper rigging is to provide a safe, controlled means of performing the lift and preventing property damage and injury. Good rigging practices you can incorporate to ensure this would include using a double sling when hoisting 2 or more objects over 12 feet in length. Make sure all rigging hooks are turned out before hoisting. When using a choker hitch, make sure the sling is long enough so the choker fitting chokes on the webbing or wire rope, never on another fitting. The socket should also be positioned so it does not cut into the sling. After the slings are in place, have the hook slowly raised until all slack has been removed from the sling and then stop. A final inspection of the sling should be conducted. Check contact points for indications of excessive stress. Make sure the sling is sitting in the center of the hook. Avoid shock loading. This can cause damage, such as bird caging on a wire rope sling. If any adjustments need to be made in the rigging, set the load before making the adjustments. Never tie a knot in a sling to shorten it. This will dramatically decrease its capacity. Never get between the sling and the load or between the sling and the crane hook while the object is being lifted. Position yourself for the best possible view of the load without putting yourself in potential pinch points. Communication is an essential element in the lift. Communication not only with the crane operator, but with coworkers too. The rigger must be familiar with standard hand signals for controlling the crane. Notify all coworkers and other personnel in the area affected by the lift. All slings, when not in use, should be properly stored in a cool, dry place to prevent environmental damage. Do not pull slings from under a load when the load is resting on it. Avoid dragging them across the floor. As a rigger, you can play a vital role in the safe lifting, traveling, and setting of loads. It is important you know the capabilities and limitations of the equipment you use and understand and respect the potential hazards. Plan each lift including the identification and control or elimination of potential hazards. Know what you are lifting and make sure it is within the rated capacity of the equipment you use. Select the proper rigging and inspect it before each use. When not in use, store it in its proper place. Effectively communicate with the crane operator and all affected coworkers in the area. Know your responsibilities and follow all established safe work practices. Proper rigging is the final means of attaching and supporting the load. It can also be the difference between dropping or setting it.